Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Dr. Anna Scott and Leland Brown, unleashing future use cases with 5G. You've opened up a lot of capability. I can do my own private networks. It's software defined, so I can add a lot more functionality to my network now. What does this unlock, Dr. Scott? Where do you take this enabling technology?
Fantastic. So we see, well, what's the best way to say it? So we are still in the early days of saying from like a bandwidth and the latency standpoint, what are the real advantages of 5G? What we're seeing with a lot of our first sets of customers is what we've already talked about is the opening up of the spectrum, like the CBRS, the ability to take advantage of the existing user equipment and now make it possible to have folks have mobile access, right? So like one use case that is not at all sexy, but actually has really huge ramifications is, can you take your laptop and onto the factory floor and start using that for full connectivity? So instead of going out with a piece of paper and a notepad and writing down the stuff that matters and then going back to your office to do your heavy work, you actually can converge those two environments. And again, it's enabled by the 5G standards, but isn't necessarily doing like a full 5G deployment. What we're seeing and what we think will be the evolution on that, and that's happening kind of in real time right now, is can you stream high definition video from a camera over 5G, do real time analytics on it, and now you've got a wireless camera that's in whatever the environment is that you care about, carry that again that video over 5G and then do your analytics on it and have that be low enough latency that you're essentially having a real time system. We're not quite there because the 5G cameras still, there's not many of them that can really operate in that environment. So often what we'll do with a 5G network is we'll still hardwire the cameras to close coupled edge compute to get that real time aspect, and then you can share up the metadata and the output of those analytics. But we're not very far away at all from saying, now that we've got that massive bandwidth and that low latency, now streaming becomes an option, and that has some really nice advantages, right?
So that brought up something else that just popped into my head. What about AR in factory?
Yeah, and
Right?
that's the other huge example for that, right? Is you can definitely do like AR headsets over Wi-Fi, but the information that we have is if you're doing a single headset, you're great. If you want to do two headsets, you're probably okay. If you want to bring that up to scale and do more like 10 or 20, Wi-Fi is not very well equipped to be able to handle that and keep a good, keep the system working in a way that's going to make everybody have the real-time experience that they want.
Right.
Whereas for 5G, that's a no-brainer, right? But
Right.
Leland, please.
Now, I was going to add, Anna, for perfect point. When you think about a 5G on-premise network, there's a couple of key elements that you have to have in place: the core, the mobile edge compute, the GNOB or RAN, and also the user plane function, which is a core function. Meaning, within the warehouse, you have all those elements. Key point is the MEC that provides you the ability to give you these applications on premise instead of having to go back to the switch, or let's say the evolved packet core of the carrier, and have that round time. Your on premise is private, is dedicated. It's a dedicated network. Wi-Fi doesn't have those functions, of course.
So this is good for security too.
Well, yeah, it provides
because my data is not going outside of my building. I can make that happen.
Right, exactly. And then when you think about it, Anna mentioned about, again, frequencies. Well, two things need to occur right now. There are certain carriers that have deployed frequencies, millimeter wave, in ways that they probably should not have, because the millimeter wave has challenges. And there's other carriers that have deployed lower frequencies. Now, I'm not saying that they really understood it. Not saying that they're not, but this, if you can see the performance of the network is different. So understanding how you deploy frequencies relative to the use case is extremely important. FR1 and FR2 frequencies react very differently in the world. And when you deploy and design a network, you have to have that level of understanding. So these on-premise deployments, on-premise network deployments, the MEC is very important to it. Your RF design is extremely important, and having all those elements on premise gives you the ability to have an independence to design it for your own use cases and needs.
All right, you threw out the word mech. What in the world?
Mobile edge
That's
compute,
mobile edge compute. All right, because I don't think everyone's familiar with that. I
right?
know I kind of know it because Anne's been
Because you
pounding
talk
it
to
on
us all
me
the
for
time. Yeah.
yeah, exactly. So MEC, so that mobile edge compute. That could be an AR headset. It could be an edge device that's feeding a bunch of data streams coming in,
Mhm.
video streams. It could be anything that's out there that's doing my edge computing, right?
Yeah, and I don't know that we've quite gotten to the level where a headset would be considered a mech. I think almost always now there's still what we would call
Something
edge
nearby
compute,
that's doing that.
right? That
Gotcha.
is that then would have a device that's then the headset device would be attached back into that mech, right?
Yeah.
And it would be doing some support functionality,
Well,
even if you're doing a lot of compute on the headset. So
I want glasses that are a mech. I do.
Well,
probably
It
a
would be
little hot
so
and a
cool.
little heavy right now.
Hey, Intel, we're going down to 1.8 nanometers, right? That's 18 angstroms. I can fit a lot of transistors
hey,
on glasses.
Moore's law
Still
still
in
exists.
effect.
Let's push it. Yeah.
Yeah,
You know.
absolutely. What about outside the factory? Because we've been talking inside the factory quite a bit. What are
Mhm.
some of those other edge use cases that 5G is really enabling?
Well, I think one of the things that we've been exploring for a while that is more kind of emergency response is how can you really use drones and how can you keep your drones connected? So, like, I think probably one of the biggest use cases, and again, this is early days. We've done some testing with this, but not full, hey, you've just come in and stood up your 5G network and you're bringing your drones to do an assessment of a damaged area. But what we have done is kind of the earlier predecessor to that, which is um, how can you get drones to be connected and have a mission and understand what's happening and go over and do the types of flyovers to say, hey, you've just had a major storm or you've had flooding or there's been a hurricane. How do you pull that kind of data together and bring all of that camera data, right? So again, we're not quite to the stream live video back from multiple drones and stitch that all together, but we're getting into the line of sight where now you can use a drone to actually gather that data, combine all that data, analyze that data, and say here are the areas where you need help, or hey, I see a person who needs immediate attention, or hey, this
So,
house is no longer there.
yeah,
And when you can do that with 5G, I mean, we can do a lot of that now. What we can't do is do that in real time, right?
but
And
5G can
have
open that up then
have the
for me.
immediate intelligence, right? And so,
Okay, so this is search
Right.
and rescue, including
right.
firefighting, because I know we're doing this in California now. We are sending drones up. They are on a 5G
Hmm.
network. That's a private 5G network that stood up specifically for firefighting. But I love the search and rescue after hurricanes or floods or whatever. Great use case.
Yeah, and just to add to what Anna stated, I mean, think about it. The metaverse and the discussions around the metaverse, without on-premise networks, I find it hard to imagine the realities of it, right? It's having mm, having edge compute points on premise allows you to have these distributed compute
Hmm.
architectures in place that can then enable use cases that can be connected to each other to be able to function. That's how I view the metaverse. It's really taking
Interesting.
advantage, without. And then this is what excites me about it, because I've been a carrier guy for years. I worked in the Department of Defense and seeing these asks, and really what excites me is that I'm able to see the realities of it now.
It's
You
starting
know,
to come together.
it's starting to come together. Yeah. So the use case that Anna mentioned, that is to me will be intense data, and it has to work. You know, for first responder use cases are just as important as to the Department of Defense. Um, and to me, will happen far more in terms of hurricanes and natural disasters as compared to wartime scenarios. So
Could you guys imagine an Amber Alert that automatically sent drones up? That would be so cool,
it would be cool. Let's
right?
do it.
We can find children that are lost. Or in
Yeah.
our area, we've had a lot of gray alerts or silver alerts recently,
Mhm.
where older people have left an old folks' home and got lost, and they found them. But having that kind of visibility is, I think there's a lot of benefit. But a lot of people are going to say, Darren, that's scary. Drones flying around taking pictures of people, and where's my privacy?
That's
Well,
a
We're
whole
getting
nother
into some
discussion on
shady, yeah.
AI.
yeah,
Yeah.
yeah,
But
Well, what it yeah, it's
it's enabling
complicated.
technology, right? What we do with that
Mhm.
technology, that's another discussion around policy that we don't want to touch today.
Yeah. Well, and another really good use case is training, right? So there's across kind of lots of different industries and lots of areas within the government as well. There's a huge advantage if you can create as close to a reality sort of training simulation, right? Without actually putting the person under threat or without spending some of the massive amounts of money if you're trying to do like a real live training session, right? So the idea of using 5G along with artificial intelligence, along with modeling and simulation, and doing that with edge compute, like is enabled by the type of mech architectures. If you put that all together with 5G, we are line of sight for having a very realistic environment so that you can actually train people very, very effectively.
right,
And then you can do things like understand how they're responding to it, what are their biometrics, what really changes over the course of that training to go into some worlds of enhancement that we can't even talk about right now with respect to helping people deal with either complex tasks or complex situations. So training, I think, is going to be one of the places that we see everything come together first, right, into some really remarkable types of situations. And I think maybe Leland and I haven't done a clear enough job to explain how important the edge compute element is of this, because as much as 5G is an enablement, much of this depends on 5G connecting to a mech as opposed to
right,
5G going up to the cloud,
exactly,
because there is still a lot of physics that come into play. So if you need super low latency, we're not talking about an architecture that goes headset to the cloud, down to a mech, then down to visualization. You really need to go headset to the mech, do your real time processing there for what's important, and then you can share data through the cloud. But for that real time experience, you need that close coupled edge
Well, Anna
compute.
and you and I have talked about this before. We also have the capability of meshing or
Absolutely.
clustering mechs
Yeah.
together. So I
Yeah.
may
right,
never even send that data to the cloud. These mechs can
Hmm.
do all the processing and analytics that I need to out on the
exactly,
edge, right? Which,
exactly
Very
right.
much so.
yeah, this could do things like smart cities,
Hmm.
smart buildings. I mean,
Yeah,
5G is really kind of that enabling technology with the concept of a mobile edge compute device all together coming together. I think we're into perfect storm to make huge changes in the industry. Now we just got to go do it.
yeah. I always say that the story of the new networks is distributed compute, right? And we're
Hmm.
connecting it through wireless connectivity, but we're really distributing compute points across the landscape, where we can now have apps sitting at the edge and enabling use cases, right? So one to one, and I'm not stating that this is a true one to one, but with every distributed compute point, you'll have a wireless connection point. Now, in some extent, if you kind of think about it, it's kind of where we're heading to. Compute wireless one to one. And the more you proliferate either or, you're going to have the other one, propagating with it.
All right. So, with all these great use cases that we've talked about, what role does Intel play in 5G? Are we just providing chips? What have we done to make this really happen?
So when you look at what it means to virtualize a network, it's really taking portions of the network, making it software defined, and then enabling an ecosystem to build or to design on top of our L15. And that's exactly what Intel has done. If you look at 4G and moving into 5G, we've taken the functional blocks of the RAN, right? And we've allowed an ecosystem to build use cases and capabilities on top of it. We've called it FlexRAN. You know, we've taken what is deemed to be the baseband, the L2, L3 layer, and enabled an ability for companies to come in and design their own baseband architectures, virtualize it, right? Not necessarily something that existed within 4G, definitely did not exist in 3G. It for 4G and 3G on back, close the box. 5G opens the box up and then allows new players to come in and build their own uh, architectures on our L15 layer.
Okay, so we
So,
we actually provided that common hardware across all of. Is that how it works? I mean, this was common. It's different than proprietary hardware. So we were the
right. So,
ones designing this common hardware. Is that the way to think about it?
So we did two things, right? Just real quick. So what Leland was describing is really the software side. So when we talked about all of these new entrants that were coming in, they Intel writing the FlexRAN reference architecture made it much easier for new entrants to pick that up as a starting point and then finish what was needed to have a full RAN solution. So
right,
FlexRAN was enabling on the software side. There's a whole other hardware story that Leland hadn't got to yet. So.
right.
Okay, sorry, Leland. I was a little confused. So hardware side, what do we got?
So honestly, I'm more than willing to let Anna speak to speak to that. But in terms of how the software side of the track, and not to try to mess up things here, but in order to kind of finish up what the ecosystem play was, that scaling and opening up the ability for the ecosystem to build out, their own flavors of FlexRAN, their own flavors of the baseband, proliferated not only across the U.S. but across the world. There are so many new
Wow.
players now that are taking FlexRAN and developing RAN solutions. Countless players now. You can even take that now into other business verticals. You're seeing the same thing. You're seeing, and within the Department of Defense, within the military vertical, you're seeing this within the first responder verticals, taking FlexRAN and developing, their own solutions based on our L15 layer. So we have an ecosystem that has grown on top of our architecture that is now providing the ability to develop these new use cases and,
I
and, and
I
new
have a question around
capabilities.
that. Did that include the old guard? Because what you basically came in and disrupted their industry.
It includes the old guard. The old guard is
So the
definitely
old guard
included.
bought in too.
The old guard bought in, though let's keep in mind, the old guard developed their solutions and made it proprietary, as you know,
Uh-huh.
that's their business case. The newer players are coming in as well because they can. The point of entry is easier as compared to what the old guard developed a closed box. Now this ability to develop your own box, if you will,
Gotcha.
or your own
That
capability, if you will.
that
And
makes a lot of
Yeah,
sense.
so there's still a lot of proprietary RANs out there that are not based on Intel FlexRAN,
right,
and those are in some of the major players, right? But I think from a how do you just open up a whole ecosystem and give newer players an advantage, right? To really come in without massive development times to really be to be a significant contributor. Definitely Intel's play on FlexRAN was all about that.
Exactly.
And then the parallel effort was really on the hardware side, right? So Leland's definitely the 5G expert. I'm much more on the applications and how do you use things. But we really did spend a lot of cycles to make sure that our COTS hardware over the commercial off-the-shelf hardware was going to work really well to support all of the baseband and RAN applications. And
Sure.
so that's another thing that's just like make sure when you're walking away from these proprietary systems that that the new systems are open and are easily supported by the same type of server that works in the cloud and works in the data center, because now you have the scale and the cost advantage.
Right.
And again, you're not going to just a limited number of players and saying, give me your hardware for my, for my baseband. You get to say, hey, that server that you use across the board, you can use it in this case too, and that's hugely significant as well, just from a price and a scalability
I was going to say
standpoint.
that's going to
Sure.
drive prices down. It's going
Hmm.
to drive more innovation in the industry as a whole. So
Yeah,
kudos to Intel.
absolutely.
We
This
need to
Kudos
is
to
give
a
them.
good
Yeah.
ourselves some
play.
kudos for this, right? I mean, we're building
Yeah.
a big, huge ecosystem to enable more compute everywhere in the world. In fact, it reminds me of something that just happened. And maybe you guys, if you don't have any information on this, T-Mobile just signed some agreement with SpaceX. Do you know about this, Leland?
I do not.
All
I'm
right, we're going to have
sorry.
to do some
No.
research. I'll cut this out of the
Yeah.
thing because I'm like, whoa, my phone will
I
actually
do
start
not.
working in the middle of Nevada now. Well, we'll have
Interesting.
to wait and see.
Yeah. But keep this inside the recording. Space, in the terrestrial domain. Okay, we tend to look at it as separate, but as time goes on, because of what Intel has really begun, hardware, software, the ability to scale this now provides the
Oh,
ability for both domains to look one and the same to us. Just like how Wi-Fi and cellular looks one and the same in your home. Imagine space and the terrestrial comms looking one and the same.
it should,
Yeah,
right?
yeah,
No, I love
yeah,
that. That's awesome.
yeah.
Guys, as always, it's been a pleasure. Thanks for
Thank
coming
you.
on the show.
Thank you, Darren, as always. Appreciate it.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.